All right, today we're going to go over sine, cosine, and tangent. So just like abbreviations, right? Sine, cosine, and tangent have abbreviations, just like Mr. Jones and Mrs. Smith. Miss MR for Mr., MRS for Mrs. It doesn't mean we pronounce anything daily. It just helps us write it faster. So again, this is the sine, the cosine, and the tangent. So if you recall, sine, SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And again, if you have your angle, your hypotenuse is always the longest side across from 90. Opposite is the one that is across from your angle, and adjacent is touching it. So given an angle in standard position means it starts on the x-axis. And a circle centered at the origin, there's point P. So if we see this here, here is our start, and this is what is called the terminal ray. It intersects it at the right. So using SOHCAHTOA, we're going to find the sine, cosine, and tangent values. So if I was to make this into a triangle, draw a right angle on down, do you guys agree that this is the x part of the triangle? Here's the y, and then this is our radius. So the sine of an angle is the ratio of the vertical displacement from P, from the x-axis to the distance between the origin and P. So our vertical displacement and the distance from the origin to P. So that is simply y over our radius. Cosine, and again, theta, we're using this angle at the origin. So cosine is adjacent over hypotenuse. So that is x over our radius. And tangent, opposite over adjacent, so that's our vertical over our horizontal. Now, sometimes you'll see tangent written as the sine of theta over the cosine of theta. And well, how does that work? We know sine is equal to y over our radius. Cosine is x over our radius. And when we divide fractions, we keep the top, y over r, times, let me rewrite that. So y over our radius times, we flip the denominator, so r over x. So our radiuses reduce out, so it's just y over x. So that's how sometimes another way you see tangent is sine over cosine. Okay, so on this next page, we're going to take a look at how each figure gives a circle at the xy plane with the center at the origin and angle in standard position. Find the value of each expression. All right, so the sine of theta. So what we can do is we can drop this down and we can make an angle here. So this is -3 and up 1. Well, what is our radius? What theorem can we do? Pythagorean. So -3 squared plus 1 squared equals r squared. So 9 plus 1 is 10 is r squared. So this is the square root of 10. So if we were to find this triangle here, and again our angle's right here, but it'll be the same as the supplementary angle, if you remember that, to 180. So our sine, opposite over hypotenuse. So this is opposite, adjacent, and hypotenuse. So 1 over the square root of 10. And we'll rationalize this, which just means to get rid of this radical in the denominator, I'll multiply by the square root of 10 times the square root of 10, because that's really the number 1. So this is the square root of 10 over 10. So our cosine, adjacent over hypotenuse, -3 over the square root of 10. And again, we can rationalize it. So we have -3 the square root of 10 over 10. And tangent, opposite over adjacent. So 1 over -3. So our next one here, let's see if we were to draw in a triangle. So our x part is 2.6, -5.4. And again, these are rounded, so these decimals probably went on a while, then they're just the rounded values. But we already know our hypotenuse, because that's our radius, and that's length 6. So sine, again, and we're going from our angle right here, so opposite over hypotenuse. So negative 5.4 over 6. And if I divide that out, that is about negative 0.9. Our cosine, 2.6 over 6, adjacent over hypotenuse. Because again, adjacent, hypotenuse, and our opposite. So this is negative 4.33. And our tangent, negative 5.4 over 2.6. So about negative 2.07. Now, this talks about in our unit circle, and what a unit circle is it's a circle and our radius is 1. So if I was to draw out any triangle here, x, y, this is saying 1. So our sine, opposite over hypotenuse, well, that's just y. Our cosine, adjacent over hypotenuse, so that's just x. And our tangent is y over x. But again, that's only when our radius is 1. Our sine is our y value, our cosine is our x. So let's check this out. As you can see here, this is 1 with our radius is 1. Okay, so I'm going to make that right triangle. So negative 0.65 backwards, negative 0.76. So sine, and again, we do just that angle to the axis here. So sine, opposite over hypotenuse. And we know our hypotenuse is 1. So negative 0.76 over 1. Well, that's just our y value of negative 0.76. Cosine, negative 0.65 over 1. So negative 0.65. And tangent, opposite over adjacent. And if we divide that out, we have 1.169.